In this lesson, we are going to be working on multiplying matrices. Now, it's a little bit different than the adding and subtracting in the fact that we have to figure out if it's possible to multiply the matrices together by using the dimensions of the matrices. So if you take a look at this little diagram right here, it tells us that the dimensions of the first matrix, the rows by the columns, and the second matrix, the rows by the columns, the two inner measurements have to be exactly the same, and the dimensions of the final answer will be the outside measurements. So if I put down for the first matrix rows by columns, and in the second matrix there are 3 rows and 2 columns, then we know that it's possible to multiply these two together because the inner dimensions match, and we know that the size of our final answer will be 3 rows by 2 columns. So let's take a look at a couple more to see if it's possible to multiply these together. So these measurements of our first matrix are 2 rows by 1 column, and the second matrix is 2 rows by 2 columns. So this one would be no, we couldn't multiply them together because the inner measurements do not match. In the second example, we have 1 row by 2 columns, and then we have 2 rows by 2 columns. So this would be yes because our inner measurements match, the 2 and the 2, and our final answer measurements will be our outside measurements. So our final answer is going to be a 1 by 2 matrix. In our next example, we have a 2 by 5 and a 5 by 1. So if we multiply A times B, the inner matches, so it's yes, we can do it, and the answer will be a 2 by 1 matrix. But if I go B times A, notice that now these do not match. So this would be no, we could not multiply it in the reverse order. So how about this? Can I measure 4 by 1 by 4 by 1? Do the inner match? No, they don't, so we can't multiply those together. All right, so let's take a look at how do we multiply matrices together. Okay, so we always do row by column. Row times column. Add products together. And then it will go into our matrix. So it really works well when you're working this out to use different colors. It's really helpful. So first we check if this is going to work. So this is a 2 by 2. This is a 2 by 2. Our insides match, so our outsides are going to be the size of our final answer. Okay, so here's how it works. You're going to take this row times this column, and because we are multiplying the top and the right side, our answer will go in the top right section. So 2 times 3, which is 6, and negative 3 times 2, which is negative 6. So a 0 is going to go in my first position. Now I'm going to multiply, and it helps to change colors, my bottom row times my first column. So 4 times 3 is 12, and 1 times 2 is 2, and so we get an answer of 14, and that's going to go in the bottom left because it's the bottom row and the left column. Now I'm going to multiply the top row and the right column together. So 2 times negative 2 is negative 4, and negative 3 times 0 is 0. So when I add the two together, I get negative 4. So it's going to go on the top right. Last, I'm going to multiply the bottom row by the right column. 4 times negative 2 is negative 8, and 1 times 0 is 0. So negative 8 is going to go in the bottom right, and that is the answer to our first multiplication problem. So let's do the next one. This is a 2 by 2, and this is a 2 by 2. And since the insides match, we can multiply, and the size is going to be a 2 by 2 when we're done. Okay, so when we multiply, we're going to do the top row times the left column, or the first column. So 3 times 2 is 6, and negative 2 times 4 is negative 8, gives us negative 2. That's going to go in the first position, which is our upper row left column. Now we're going to do the bottom row and the left column. 12 times 2 is 24, and 4 times 0 is 0. So we're putting 24 in our bottom left position. Now we will do the top row and the right column. So 3 times negative 3 is negative 9, and 1 times negative 2 is negative 2, and that gives us negative 11, and that's going to go in the upper right position. Now we'll do the bottom row and the right column. 12 times negative 3 is negative 36, and 0 times 1 is 0, and that gives us an answer of negative 36, and that goes in our bottom right hand position, and this then is our final answer for multiplying b times a. So what do you notice about multiplying a times b and then b times a? We don't get the same answer. So matrix multiplication is not commutative. Order matters. In other words, I can't multiply the two together and get the same answer like I did when I took 3 times 2 and got 6, and 2 times 3 I get 6. It does not work that way with matrices. All right, so let's be more complicated. To find our, to see if we can do this problem, we have 3 rows and 3 columns. And the second matrix has 3 rows and 2 columns. Because the inner measurements are the same, we can multiply. So our answer is going to be a 3 by 2 matrix. So let's start with the top row and the left column. The only difference this time is we'll have 3 numbers that we're multiplying together. So 4 times 10 is 40, 0 times 0 is 0, and negative 6 times 9 is negative 54. So when I add those together, that's going to go in my upper left hand position, which then will be negative 14. Now I'm going to do the middle row and the left column. 1 times 10 is 10, 0 times 3 is 0, and 6 times 8 is 48, and I add them together to get 58, which goes in the middle position of the left side. Now I'm going to do the bottom row and the first column. So negative 1 times 10 is negative 10, 5 times 0 is 0, and negative 11 times 6 is negative 66. So negative 10 plus 0 plus negative 66 is negative 76, and that goes in the bottom left-hand position. Now I'm going to do the top row and the right-hand column. So 4 times 1 is 4, 0 times 3 is 0, and negative 9 times negative 2 is positive 18, and that adds together to be 22, and it goes in the upper right side because we did the top row and the right column. Now we're going to do the middle row and the right column. 1 times 1 is 1, 3 times 3 is 9, and 8 times negative 2 is negative 16. So when we add them together, we get negative 6, and that goes in the middle position on the right-hand side. Next, we are going to multiply the bottom row and the right column. Negative 1 times 1 is negative 1, 5 times 3 is 15, and negative 11 times negative 2 is 22. So when we add these together, negative 1 plus 15 is 14, and 14 plus 22 is 36, and that goes in the bottom right-hand position, and that would be our final answer, which is a 3 by 2 matrix. In the next section, we are going to do a specific position. I want to, first of all, make sure that this is possible. This is a 2-row by 3-column matrix, and this is a 3 by 2. So since the inners are the same, the outers will be a 2 by 2. And it says find the element in the second row, third column. Well, we aren't going to have a second row and third column, so we better change that to second row, second column. So I want to find the second row, so I'm going to do row 2, the second row, and the second column. So that's going to be 5 times 0, which is 0, 2 times 1, which is 2, and negative 1 times negative 4, which is 4. So my answer in the second row, second column, would be 6. Now if I reverse this and I do b times a, I get 1, negative 3, 0, 5, 2, negative 4. And I have 4, 0, negative 2, 1, 3, negative 1. First I have to check that I can multiply these. So this is 3 rows and 2 columns, and 2 columns and 3 rows. So I can multiply them together. So it asks me for the third row and the first column. So I'm going to multiply that together. 4 times 0 is 0, and 4 times negative 4 times 0 is 0. So my answer would be 0, and that would be in that position. So now it's your job to try to find the product if possible. So when you're doing this, you need to find the dimensions and then multiply them together if it is possible.